The desert, one of the Earth's most prevalent terrestrial biomes, has falsely garnered the reputation of a lifeless, barren wasteland. Yet, this is far from the truth. Much to the contrary, deserts are biologically rich habitats, some being among the planet's last remaining areas untouched by human activity. Covering up to 20% of the land surface on Earth, deserts are found on every continent other than Europe.
Contrary to popular belief, a desert is not necessarily stricken with blistering temperatures, but rather afflicted with minimal amounts of precipitation. Any area that receives less than 10 inches of precipitation annually is technically classified as a desert. Thus, deserts can be and often are extremely cold. Such biomes are renowned as cold deserts, where temperatures can drop to as low as -2 to -4 degrees Celsius. The famed hot desert, on the other hand, is the more prevalent counterpart of the cold desert. Usually located near the tropics of Cancer and Capricorn, 30 degrees north in latitude of the equator, sunlight in these environments is present about 21 hours a day. Sunlight warms to the sand to such an extent it is said to be possible to receive second and sometimes third-degree burns from simply walking barefoot on the sand. Namely locations include North Africa, Mexico, Western Australia, and South Africa, and average temperatures usually range from 20 to 25 degrees Celsius. The temperature is also known to melt or explode cell phones, or at least damage them beyond repair if it encounters the treacherous sunlight. Rather than rainstorms drowning the biome, sandstorms rage feverishly across the desert. These sandstorms last hours, sometimes days, drowning plants and animals in layers of sand. This is a common abiotic cause of death for many plants and animals because, ironically, some will never see sunlight ever again. With the abundance of sunlight, plants prevent the respiration of water with crassolution acid metabolism. With crassolution acid metabolism in a plant opens its stomata during the night and in return stores CO2 inside. After a beautiful sunrise, the stomata opens once more, releasing the CO2, allowing for minimal photorespiration. Quite obviously, the process is limited by the size of the stomata.
Through its amount of minimal vegetation, the desert acquires a 0.032 kilogram per meter squared per year average net primary productivity. The plant organisms inhabiting a desert ecosystem possess adaptations that allow them to thrive in a seemingly inhospitable aridity. Succulent plants, such as cacti, store water in fleshy leaves, stems, or roots, structured in compounds or cells from which water is not easily lost. Such plants usually possess a non-porous covering on their leaves that reduces evaporation. One example is wax. Like plants, animals must adapt to the severe lack of precipitation and moisture in a desert climate. Animals in the desert, such as this camel, often obtain precious amounts of water through the consumption of other organisms. However, many desert animals rarely have the opportunity to drink freestanding water, and this camel is likely among that group.
Desert soil quality is almost very poor, but it is its lack of moisture, not nutrition, that poses the single greatest limitation to the amount of plant life that can prosper in the treacherous biome. In order to cope with the permeable surfaces, composed mostly of sand and rock fragments, that easily lose water to evaporation, different plant species take up different adaptations. Some plants, such as the sagebrush, adapt huge root systems that are long enough to reach underground water sources that are protected from evaporation into the atmosphere. Others, however, cope with the extreme moisture fluctuations of the surface soil by absorbing large amounts of water in short periods of time through long, shallow roots, and subsequently storing it in enlarged cell vacuoles. The cactus, a succulent plant, is a prominent example of a plant that utilizes a storage mechanism.
Like plants, animal species also host a variety of mechanisms to deal with the severe heat and dryness that accompany the environment. This frog burrows underground during the heat of the day to remain cool and absorb soil moisture. This frog, specifically, has a bladder filled with water that provides an emergency source for an aborigine. Such species will often estivate in periods of sustained dryness or high temperature. Estivation is the desert organism's equivalent of hibernation and is simply a prolonged state of inactivity and lower metabolic rate. Many such animals, like this nightjar, are nocturnal and only carry out their daily functions at night when temperatures are much lower than the day. During the winter months, temperatures can drop below freezing. Furthermore, for animals like this nightjar, the night is a perfect hunting environment. Such organisms have a superior sense of sound and extraordinary eyesight to locate prey in the dark.